Now, whenever we heard the term oceans, the first thing came into our mind that is a large body of water, and any water within our Earth system is basically represented in the hydrosphere. That means the sphere which contains water. The hydrosphere is distinguished from the lithosphere and atmosphere. Basically, hydrosphere includes all the regions of the earth, including the liquid water, the frozen water. Frozen water includes the solidified ice over the mountain tops as well as the ice floating on the water, the surfacial fresh water, that is the river, ponds, lakes, as well as the subsurface water. So together, all these various occurrence of water come under the common term hydrosphere. Now, if we look at the various occurrence of water, mostly they are liquid in state. Also, there are some vapor state found in the atmosphere, and the important part, one important part, that is the solid part, that is the frozen part of the water, which is mainly found in the polar regions or in the high altitude mountain tops. Now, this frozen solid water is also defined under a separate term that is known as cryosphere. So, cryosphere indicates the frozen solid water that is mainly restricted to the uh, polar areas and in the high altitude mountain tops. Now, if we look at the distribution of water, because we know in the land, in the earth's surface, the chemistry of water is not same in all the places. If we look at the distribution of water throughout the earth's surface, it is found that almost one third portion of the earth is covered by water, and ocean plays a large uh, factor, a large portion within this one third portion. You can see that the within this one third of the total land surface, oceans cover about 97.2%. So therefore, ocean plays a vital role in the hydrosphere. The rest of the 2.8% is covered by the uh, frozen ice, the freshwater rivers or lakes, the water trapped within the soil, as well as the atmospheric vapors, that is the uh, gaseous state of water found in the atmosphere. And we all know that in atmosphere, the percentages of water is found about 0.001%. So, although very negligible, but its effect is hugely important. Now, we all know from our previous knowledges that the water what we found in the earth surface, that is not fixed to that position. With time, in continuously change its form and thereby circulates throughout the earth, starting from the oceans by taking intense heat from the ocean surface as well as from the land areas. The water gets evaporated. This evaporation creates the gaseous state of water with rising upward. The water vapor becomes cooled. It forms clouds in combination with the dust particles. That cloud moves toward landward side, and when they reached a suitable condition in the land, precipitation occurs from that cloud in the form of rain or sleet or ice crystals or snow. So different form of precipitation are found in the land areas. Now, after precipitation in the form of water or in the form of ice, that ice will melt and that precipitated water will flow towards downslope, towards the uh, higher gravitational areas, and ultimately meets to large lakes or ocean bodies. Now, some of the water flows over the surface that we know as surface runoff, and some of the precipitated water goes below the surface, that is infiltrate within the pore space of the soil and underground rocks, and that underground water moves along the pore spaces of the sediments or pore spaces of the rock towards downslope areas, that is known as groundwater. So in this way, by different processes, by taking energy from the earth's surface and sometimes releasing energy to the atmosphere, the water change its form from liquid to gas to solid or liquid and again meets to the ocean body. The water encircles all the places, or water circulates all the places of the earth. So this cycle is known as water cycle and hydrological cycle. Now, hydrological cycle is one of the important processes by which all the areas, more or less all the areas over the earth's surface experience some amount of activity of water. Without hydrological cycle, there will be no cloud formation, there will be no precipitation. And depending on this hydrological cycle, different physical and chemical processes are also take place over the earth surface. Now coming to the ocean interactions with the atmosphere. So you can see that there is a large residence of water in the oceans, and whenever atmosphere or wind blows over these oceans, definitely it will interact with these large ocean water bodies. Now, how they interact, that we will discuss in the next few slides. The oceans and the atmosphere are the two main reservoirs of water in the Earth's hydrological cycle. The two systems are completely linked to one another and are responsible for Earth's weather and climate. as I already told you, it is the hydrological cycle by which the different forms or different states of water that we found over the Earth's surface is gradually moving in a or change in a cyclic way. Now, if there is no evaporation occurs over the ocean surface, then there will be no question of forming any clouds. So there will be no rainfall or there will be no precipitation of ice in the high altitude areas or in the polar regions. So by stopping one process in the hydrological cycle, the entire cycle can be choked. So in this way, all the processes, the evaporation, evapotranspiration, formation of clouds, the precipitation, and surface water movement, all they are linked in a complex way to one another. The oceans also help to regulate temperature in the lower part of the atmosphere. The atmosphere is in large part responsible for the circulation of ocean water through waves and currents. Atmosphere and oceans are the independent system. Although we read them or we study them differently, but they are mutually interdependent among themselves. Major fraction of the incident solar energy is used in the evaporation process from the ocean body, by which the large amount of oceanic water goes into the vapor phase into the atmosphere. Now, we can already know that solar energy, when they reach the Earth's surface, they fall at different angle, and also the thickness of atmosphere varies from equator to poleward. The atmospheric thickness is maximum in the equatorial region, whereas it minimizes towards polar region. So whenever solar energy reaches the Earth's surface at equatorial region, it falls directly or almost perpendicular. So per unit square area face more energy, whereas as we move higher through the different latitudes, here the insolation energy reach at an angle with the Earth's surface, and thereby per unit square area gets lesser amount of energy compared to the low latitude areas. Now, apart from this angle of incidence, the atmosphere thickness also plays a significant role in the amount of energy received at Earth's surface at different latitude conditions. Because we know that the atmosphere basically contains lots of gas molecules along with lots of dust particles, some water droplets are there, ice crystals are there. Now, whenever energy on solar energy falls on these molecules or on these water drops or ice crystals, some amount of solar energy is either absorbed or reflected back to the space or scattered. Now, in an area where there is thick atmosphere, the loss of energy will be comparatively more compared to the area where the atmospheric thickness is relatively less. So all the processes, that is absorption, reflection, uh, scattering, those will occur more in the equatorial regions compared to the uh, high altitude areas. Now, in this way, the atmosphere itself retained some amount of energy, but whatever may be the uh, difference in energy reaches in the Earth's surface due to this atmosphere thickness difference. The main energy difference received at the Earth's surface is due to the angle of incidence of the solar radiation. Now, due to the difference in solar energy over the Earth's surface, that cause differential thermal heating over the Earth's surface. So there is a net heat gained in the equatorial region and heat loss found in the high altitude polar regions. And due to these different thermal conditions, there forms certain high pressure and low pressure areas, and the wind movement starts from high pressure areas to the low pressure areas. Now, during this movement of high pressure areas to low pressure areas, the wind mainly move as surface flow, because in the low pressure areas, because of the low pressure, the surface wind goes aloft, goes up, and the vacant is filled up by the dense cold wind coming from the high pressure areas, and this wind blows at surface wind. Now, when the movement of wind occurs over a large body of oceans, then at the contact surface between the atmosphere and the water body, there a friction occurs between these two mediums. The top surface of the water body thereby experience a frictional drag, because the water body is basically constant. Now, over this constant or static body, if any moving object blows for a longer period of time, blows for a longer distance, then definitely a friction exists between these two mediums. And if this friction acts for a longer time, for a longer aerial span, then the medium, that is the water body, that will experience a frictional drag, and due to this frictional drag, the waves formed on the oceanic body. So what happens in this frictional process by which the waves formed in the large body of water? During this interaction of atmosphere with the oceans, due to the friction, the ocean water body restricts the surfacial wind to move. So there is a exchange of energy at the interface of the ocean and atmosphere. So the energy which was previously in the atmosphere that is transferred to the oceanic body along the interface of ocean and atmosphere. And due to this transfer of energy from one medium to another medium or one body to another body, the waves generated in the oceanic body. Now, the transfer of energy is largely depend on the size of the water body as well as the uh, time, that is how long the interaction will occur, and lastly the energy condition of the moving wind. Often you can see that in a small pond we did not found any kind of waves, but in a large lake or in the oceans there are always waves formation occurs. So why this difference? The same medium, the same water in a small pond and in a large lake behaves differently. That is because of the aerial span of the water body. So more and more aerial span of the water body, the interaction between ocean and atmosphere occurs more and more, and thereby transfer of energy happens more. So in the larger water bodies, this transfer of energy creates the formation of waves. The energy exchange in this interaction process, although they forms primarily the waves, but this energy exchange also take place in the form of exchange of heat, that is known as sensible heat, that is responsible for changing the temperature of the water body, or vice versa. Next, the change in moisture content of the atmosphere with the help of latent heat, that is if the water is very hot compared to the superficial atmosphere, then the water takes some amount of heat from the superficial water and gets evaporated. Similarly, if the water is cold enough and the overlying or overblowing wind is relatively hot, then coming in contact with the uh, water surface, some amount of vapor within the atmosphere can be precipitated or can form water droplets by taking latent heat from the sea surface condition. And lastly, the momentum, that is the wind stress. And due to this wind stress, actually, the waves are generated. But one thing should be noted here, that all these change or exchange in energy are primarily happened at the superficial condition, that is the interaction or the boundary between the atmosphere and the ocean. Now, the exchange of heat, moisture, and momentum are represented usually as fluxes, which is defined as the rate of exchange of energy per unit surface area of ocean atmosphere interacting surface. So how much heat is exchanged, how much moisture is exchanged, or how much wind stress, that is momentum is exchange between these two medium, that is represented by the rate of exchange per unit surface area along the interacting surface between ocean and atmosphere. The large difference in mass between air and water also implies a large difference in heat capacity. We already know that water has almost the highest heat capacity, so it can retain a large amount of energy. Now, what is heat capacity? Heat capacity is the property of any object, any substance by which the temperature of that substance can be increased by 1 degree, and for this the amount of energy required. Now, to increase the temperature of water by 1 degree, water requires almost 4 times energy than that of air. So you can get an idea that the energy, total energy stored in a aqueous body is much higher compared to the atmosphere. A mere 2.5 meter depth of water has the same heat capacity as the whole depth of the atmosphere. So you can see only a 2.5 meter depth of water body can have the same heat within it compared to the total atmosphere depth. So whatever heat is stored in the total atmosphere, that can be simply stored in the 2.5 meter of depth, and this can be explained with the help of high specific heat or high heat capacity of water body. The role of the ocean in climate variability results partly from its large heat capacity to store and thereby distribute heat from one place to another place. Now, if water gets the high amount of energy and thereby stored that energy within its water body within itself, and if there is no movement, more distribution of this heat occurs, then the water of one region will face continuously heat, continuous energy receipt, and thereby continuously heated up, whereas the water in other regions, they becomes completely cool. So they are found an extreme situation within the water body also. One area becomes extremely heated up, another area becomes extremely cooler. The large heat capacity of the ocean is of importance for seasonal changes also. In the long term, each hemisphere loses by radiation about as much heat as it receives. This is not true of an individual season. The excess heat gained in summer is not transported to the winter hemisphere. So, although there is a circulation of heat from the hot temperate regions water to the cooler regions water, but this transfer of heat is not uh, very fast, and in the seasonal time span the summer heat is not immediately transported in the to the winter hemisphere, but instead it is stored in the surface layers of the oceans. Because of this availability of stored heat, the ocean surface temperature changes by much smaller amounts than the land surface, and the land surface we know that they cannot store much heat. So always there exists a differential heat between the land surface and the ocean water body. And due to this differential heat, we know that there is a circulation or movement of wind happens due to the occurrence of high pressure and low pressure systems in land and ocean areas, and these pressure systems alters their position during a 24-year time span, that is known as sea bridge and land bridge. Also, the seasonal change of occurrence of high pressure and low pressure also found to occur whenever a large landmass is found to be surrounded by a huge oceanic body of water. So during the seasonal time, the land and oceanic body, due to their different heat capacity, they will form differently the high pressure and low pressure zones. Say for this example, during summer, warmer land, that is low pressure zone exists in land and high pressure zone exists in ocean. So wind movement is from ocean to land. And in India particularly, this will cause the southwest monsoon, that is the uh, rainy season, the monsoon season, which will face in the next few days or next few weeks. That is due to the extreme heating of the landmass during summer. At the same time, during winter in the northern hemisphere or during uh, winter in India, the landmass becomes sufficiently cooled, but because of the heat capacity or high heat capacity of oceans, the ocean water still remains warm. So the pressure zones alters their position during winter time. The ocean water, over the ocean water exists the low pressure zone, and over the land exists the high pressure zone. So again, wind movement happens in this time during winter, but this time the movement is opposite from land to sea. Now, besides energy conversion of or exchange of energy, there is also exchange of mass occurs during the interaction of atmosphere and wind. This mass exchange includes the exchange of fresh water in the form of precipitation by rainfall or ice, and that precipitated water move along downslope by surface runoff. The melting of sea ice or melting of land ice also creates runoff, and evaporation from the ocean water adds water vapor to the atmosphere, and that will be ultimately precipitated in the land areas. So you can see the mass of water also exchanged from the oceanic body to the land areas. This with this in exchange of mass from the ocean to land areas, along with the change in state of water, the gases are also exchanged during the interaction of atmosphere to the seawater. The gas exchange occurs mainly found in case of oxygen, in case of methane, nitrous oxide and carbon dioxide. Now, if we look at one simple example, that is the transfer of carbon dioxide along the interface of ocean and water. The transfer of carbon dioxide from atmosphere to ocean or the reverse, that is ocean to atmosphere, mainly depend on two factors. First is the biological pump, that is the biological activity of organisms within the ocean body, and second is the physical pump. Both in processes by which or due to which carbon dioxide exchange occurs, that will primarily affect on the partial pressure of carbon dioxide in the interface of atmosphere and ocean. So depending on the partial pressure of carbon dioxide, the movement of carbon dioxide occurs either from atmosphere to ocean or from ocean to atmosphere. Now, in case of biological pump, the transfer or the exchange of carbon dioxide is found to be highest in the ocean regions where the surface concentration of carbon dioxide are lowest, because I already told you that it will affect ultimately the partial pressure of carbon dioxide. Now, the partial pressure of carbon dioxide means the concentration of carbon dioxide in simple form. So, due to the biological activity of the ocean water during their photosynthetic process, they will intake the dissolved uh, or the carbon dioxide within the ocean water. So there will be a decrease in concentration of carbon dioxide found in the oceanic water. Now, if we compare the concentration of carbon dioxide at this interface, there will be a change in partial pressure, or there will be a difference in partial pressure of carbon dioxide found to occur at this interface. So at this point, due to high biological activity, due to high amount of photosynthesis, as the carbon dioxide within the ocean is used up, so there is a constant supply or constant mixing of constant adding of carbon dioxide occur from the atmosphere to the oceans. Now, this adding or this mixing of carbon dioxide from the atmosphere is largely depend on the wind speed. Where the wind speed is uh, highest, the mixing of carbon dioxide from atmosphere to ocean is also occurs in a high proportion. So biological activity, particularly the photosynthesis, plays the vital role governing the exchange of carbon dioxide between atmosphere to ocean. The second way is the physical pump. The oceans primarily act as a large reservoir of carbon dioxide. Now, the ability of ocean water to absorb carbon dioxide increases with decrease in temperature of the water. That is, cooler water can dissolve or can absorb more carbon dioxide compared to warmer water. And this happens due to the solubility of gases with changing temperature according to the second law of thermodynamics. Now, what basically happens that during this physical process, uh, one simple reaction happens. That is, carbon dioxide reacts with water and formed H2CO3, that is carbonic acid. Now, H2CO3 is not very stable form, so ultimately it will form some carbonates or bicarbonates ions. Now, in this process, in this reaction, that is from water to carbon dioxide, some heat is released. That is the process. This process is exothermic. Similarly, the opposite process can also take place. That is, from carbonic acid, it will again form the water and carbon dioxide. And this opposite process is endothermic. That means the reaction to take place from carbonic acid to water and carbon dioxide, it requires some amount of heat. Now that heat is basically taken from the warm water situation or warm waters. So thereby, during cold water or the regions which have cold water, particularly the high altitude areas, the polar regions which have the temperature of water relatively cooler compared to the water in the equatorial regions. In these regions, the in presence of heat, the dissolvement or the absorption of carbon dioxide into the water will happen more, whereas in equatorial region the absorption of carbon dioxide will be less. So that is why the solubility of gases decreases with increasing temperature. Now, the primary concern or the main concern about this fact is that in the present day we are experiencing a relatively hot condition, and gradually the average temperature of the earth is increasing day by day. So we are evidencing a global warming situation. Now, if global warming happens, then this reaction, the opposite reaction, that is from carbonic acid to water and carbon dioxide, will happen more easily. That is, instead of absorbing carbon dioxide from the atmosphere and the ocean water acts as a reservoir of the atmospheric carbon dioxide, in the time when global warming occurs, that is the oceanic temperature will increase at a uh, sufficient rate, then instead of absorbing carbon dioxide, the ocean water itself release carbon dioxide to the atmosphere. So the opposite thing now take place, and that will be alarming to us because we know that carbon dioxide is a greenhouse gas. So, with increasing surface temperature, with increasing human practice and all other things, we are producing some carbon dioxide more and more and dump them in the atmosphere. And in nature also, due to the increased temperature condition, the naturally stored carbon dioxide within the ocean water body that will also start to release carbon dioxide to the atmosphere. So more and more dumping of carbon dioxide will occur into the atmosphere. So that will increase the warming period in a more intense way, and that is alarming to us. Thank you. That's a very brief idea about the exchange of mass and energy or exchange of gases when the oceans and uh, atmosphere, that is wind, interact among themselves. In the next class, we will learn how the interaction of ocean and water primarily govern the movement of ocean water. Thank you.